Hello everyone. In this video, we'll understand what do we mean by force of interest. Consider a compound interest rate of 0.1 per annum. Let's say this 0.1 is per annum. Then the discount rate will be 0.090909. How did we get? Because there is a relation we saw earlier. D is nothing but I plus 1 plus I. So in this case, it is 0.1 divided by 1 plus 0.1 or 0.1 by 1.1. If we calculate that, we will get this value 0.090909. Right. Now, if we consider this as the rate of interest, compounding interest, then our I1 will be the same only. And similarly, D1 will be this only. Means for 1 year conversion, the interest rate and discount rate will be the same, whatever we got initially. But if it is for 2 conversions in a year, then we can find out this I2 like I can put it as IP. If I want to find, it will be P times 1 plus I to the power of 1 by P minus 1. By applying this formula, I can get these values. Means 0.090618 for I2. Means if it is I2, then it will become 2 times 1 plus 0.1 to the power of 1 by 2 minus 1. If we calculate that, we will land up with this same answer, whatever I made the table, that answer we will get. Similarly, if I want to find out the discount rate for 2 periods, or I can generalize it, P periods, which will be P times 1 minus of 1 minus D to the power of 1 by P. Means if I want for 2 periods, it will be 2 times 1 minus of 1 minus 0.090909 to the power of 1 by 2. If you evaluate that, we will get this 0.093075. So for various periods, for example, if there are 4 conversions in a year, 8 conversions in a year, 16 conversions in a year, like that, I just wrote all this. We may notice one thing, this when the P increases, we may notice when P increases, then we may note this IP may decrease. Not may decrease, it will decrease. And you may notice this DP will increase. So if P increases, IP is decreasing. See, here it is 0.1, then 0.97618, then 0.96455, keep on reducing. Whereas if you look into this D, it is actually increasing. Then when the P becomes very large, when P tends to infinity, means it becomes very large. Here I didn't do much bigger number, but even if I consider 116,384 itself, we may notice that the IP and DP values are merging together to one constant number. So the IP will be equal to DP when P becomes very large. That particular rate of interest, we call it as force of interest, and we denote it by delta. That is the force of interest. So if I try to plot this considering P values in X and IP values in Y, even DP values in Y axis, we get a graph like this. Means IP, this blue color is IP, and then this orange color or rust color is DP. We may notice that this IP is keep on reducing, whereas DP is keep on increasing, and it converges at a particular thing. This particular point is our delta, right? So that we call it as force of interest. So from this data, we may notice that among all this IP and DP, the least is this D1. That means I can always say D1 will be lesser than D2, is lesser than D4, lesser than, and so on, lesser than this delta, and then I dot 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 dot, I'll put I16 lesser than I8, lesser than I4, lesser than I2, lesser than I1. Because you may notice from the values, whatever we have, the least value is D1, highest value is I1. That's why I wrote like this. So this is a particular inequation which is very much valid, a valid inequation, right? Then in mathematics, we have what is called as a Euler's rule. Euler's rule, which states that the limit value or limiting value when n approaches infinity of 1 plus x by n to the power of n will converge to e to the power of x. Now, let us consider our annuity factor. Our annuity factor, we know it is 1 plus IP by P, the whole thing to the power of P. Now, if the P value is becoming larger and larger, what we had seen in the above, like we started with 1 and slowly we increase the P value. So again, I'm writing that if P approaches infinity, then the limiting factor or limiting value of this accumulation factor will be limit P tends to infinity 1 plus IP by P whole power P. This will converge to now e power I P. Or since we are substituting P, or P is taking a larger value, I should write this thing as, instead of writing IP, I'm writing now as I infinity, right? And this I infinity is considered to be delta. So I will say where I infinity is delta. And this is annuity, accumulation factor, which we know it is 1 plus I. So I can equate this to 1 plus I. I'm sorry, not this, the E value. This one is 1 plus I, which means our delta will be, because if I take natural logarithm on both sides, what will happen is delta natural logarithm of E equal to natural logarithm of 1 plus I. This is nothing but 1. So delta will be natural logarithm of 1 plus I. So I can simply write it as 1 plus I. So if I want to find out the force of interest, I can find out the natural logarithm of 1 plus I, which will give me the force of interest, right? So that is about force of interest. We will, in our further videos, we will understand. Just a moment. Sorry, something gone wrong. Let me rewrite it. Just a moment. Let me rewrite this. This we know it is accumulation factor, so it is 1 plus I. So since e power delta is 1 plus I, natural logarithm of e is ln of 1 plus I. This is 1, so this will be that's what I wrote earlier. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.